Hey everyone. Today I just want to talk a little bit extra about what our lesson today was about, which is arguing in science, and also a little bit about Rachel Carson. Um, the book that Rachel Carson wrote that we read about today is called Silent Spring. I actually have a copy of it at home. Unfortunately, today I am not at my own apartment. I'm at my parents' house for visiting for a week out on Long Island, so I don't have it with me here. But once we get back to school, I will definitely bring it in and put it on my bookshelf for next year so that if you want to, you can read it as a personal reading book. The main thing I wanted to talk about was how arguing actually works in a real science lab, since a lot of, especially fifth grade science teachers, haven't done actual science in a real lab. Thought it would be an opportunity to share with you guys a little bit about what it's actually like. So scientists do spend a lot of their time arguing and trying to pick apart each other's ideas. And this isn't because they're trying to be mean to each other. It's because that when they finally go and share those ideas with the community in a scientific journal or a book or some other way, everybody wants their ideas to be as good as possible and that evidence to be as strong as possible. So that way, if somebody else decides to test it later, they're not going to figure out that they're wrong and that they've been misleading all the other scientists all along. So remember, the goal of science is to try to find out, like, as close to accurate, like what is actually going on. So when I was in lab, we would have lab meetings a couple times a week where we would take a look at how each other's experiments are going. We'd present what we were doing, and then we'd try and pick apart like what the person did to see, okay, is there a way you could have done this better? Or if they were having trouble with their experiment, we'd try to help them out and figure out, okay, what could we do to fix this to make it work the way that it's supposed to? So that's what we do every week. We'd also have journal clubs where we would take a look at stuff that other scientists have published and put out into scientific journals and talk about them. So part of that is just looking at it, figuring out what new ideas are in there and talking about those. And then after that, we would talk a little bit about, hey, were their methods good? Did they actually show what they are claiming to show here? And if not, like, what did they do wrong? Um, and then making sure, and we weren't the only ones doing that. There were labs all over the world looking at these new articles and trying to figure out, okay, did these guys do every single thing right that they should have done? And before you publish that paper, a lot of times you'll go and present your ideas in talks, either at your university or at a big conference. And so you get up on stage, you talk for 10 or 20 or 30 minutes, depending on how interesting your results are and whether you're like a student or somebody who's like already really famous and gets a lot of extra time. And then at the end of that, you always have this period of time that's almost as long as the entire time you talked, where everybody in the audience, who are all super smart scientists, are going to ask you questions. And a lot of those questions are ones that they're going to try and figure out, okay, like, why did you do it this way? What, like, this doesn't seem right. Why did you do it? And it's like, in that moment, it's hard to not take that personally, because you're up there in front of a bunch of people and this guy's basically saying, hey, what did you do here? That's totally wrong, isn't it? And then you have to justify like why you did that and why you didn't do the other thing. And it's not necessarily out of meanness that they're doing that. It's that, hey, we want everybody here to have the strongest evidence possible and know exactly what's going on, and making sure that what you did to support your claim actually supports your claim. Because if that claim's correct and you publish that work, then a lot of other scientists are going to base their experiments off it. And if what you did isn't correct, or there was something wrong along the way that nobody caught, then a lot of other people are going to waste a lot of time and money trying to figure out other things based on what you said was correct. So really, like, science is all about arguing. We scientists spend a lot of time arguing, and probably spend all, like, most of the time when scientists are in a room together, they're going to be arguing about something. And again, it's not that arguing is a bad thing. It's not that they don't like each other, although sometimes they don't like each other. They're people too. But it's always with the goal of trying to find out what is the most correct way to go about the experiment and what's the strongest way to show that evidence and the strongest way to support whatever claim you're making, and making sure that that claim is as close to correct as we can get based on what we know now. So just thought I'd add that in for anybody who is interested. And if you have any questions on this or anything else from today's lesson, I'm going to go ahead and I think add a question onto today's assignment and post this video with it. So that way, if you have any questions, you can ask it there. All right, so I'll see everybody tomorrow. Remember, I'm in Zoom today at 10 to 11 and also 2:30 to 3:30. So see you there. Bye.